This is test ID 63, component ID 00. It's the Evap system testing for a pinch hose. The CID 00 indicates we have a maximum limit. Now the PCM runs a leak detection pump to build pressure in the Evap system, and the pressure K is used for leak determination. But this is a specialized situation where the pressure builds too quickly. Now the values aren't converted into measurement values by Chrysler, so use the data as a relative indication of performance. We'll use vehicle data to show the typical values. Now, here is 63. We have a maximum of 39 and a measured value of 6. We've passed it easy. Remember, this is the opposite. If it reaches the maximum, it's pumping up far too fast. We have a kink in the system, and it's not really creating a pressure in the entire Evap system. Now, you're going to be needed doing some testing here. You're going to have to use the solenoid switch test and other things to see how it works and to see how quickly it pumps up. Here's the connector, and here's the diagram. You're going to have a good diagram to understand how this works. Now, we're going to see how to activate the solenoid. We can see with a red wire at the top going in pin 2 is B+ to the switch and to the solenoid. This PCM is going to supply ground down in the bottom in order to activate the solenoid. When the solenoid activates, it opens a vacuum valve which allows vacuum to pull the leak detection pump up, which opens the reed switch. Now, the PCM removes the ground when it sees the sense switch open because it knows the diaphragm is up, and a return spring forces the diaphragm down, which pumps pressure into the Evap system, and we're going to show you this in detail. Now, this action has to continue until the diaphragm pumps up the pressure in the Evap to cause the switch to remain open. It's determined by the strength of the return spring. This return spring is about 6 or 7 inches of water in pressure. Now, we're going to go look at a good animation that shows all this happening. But now that you have an understanding, you should be able to keep up with the animation. We're going to use some great animation from Star Envirotech. People make great smoke machines for Evap testing. We're going to be connected to our canister here, where we'll be sucking fresh air in, and it'll be coming from the vent up here in this diagram. Now, this is normal operation. We're going to block manifold vacuum with a valve at the top. This is going to keep the vent open so normal canister purge can take place. What we're going to do when we're ready to unblock this vacuum that's been blocked is we're going to energize the solenoid. When the solenoid is energized, we pull that valve back. This is going to open it up and expose that passage, and it's going to pass vacuum down to the top of the diaphragm. And when vacuum is applied to the top of the diaphragm, several things are all going to happen at one time. So pay careful attention. First thing going to happen, the diaphragm is going to be pulled up, and we're going to close the vent. This seals up the Evap system. The reed switch opens, and the check valve opens to allow fresh air to come in and fill the chamber. This is the first phase of getting ready for the leak check. Now, just pulling the diaphragm up does not make a pump. To function as a pump, the diaphragm is going to have to work in a cycle up and down and have a spring that's calibrated to push it down. Now, in this particular case, the diaphragm return spring is calibrated force of 6 to 7 inches of water. When pressure builds in the Evap system to 6 or 7 inches, the diaphragm stays up. Now, the PCM is going to activate it every time it sees it goes down. If pressure builds too quickly, the Evap system is restricted. That's one finding. If pressure never builds, the system has a gross leak. Once the PCM determines that the system is staying pumped up, diaphragm is staying up, it can measure the time to calculate the amount of leaks we have, major leaks, minor leaks. So you need to understand a little bit how the system works like this in order to diagnose. We're going to use a diagram from the MPC Smart Spec. Now, we know we can't wait for the Evap monitor to run to test this, so we're going to start checking things. B+ has to be supplied here when we're running and the key is on. With the engine running, activate the solenoid by applying a ground to this circuit. This is the same thing the PCM does. Engine vacuum should be applied to the diaphragm, which should cause the switch to open. Now, running the switch open one time is not going to do it. You're going to need B+ to the solenoid, a good ground connection, and manifold vacuum to make the switch stay activated. What we're going to have to do is cycle it off and on to get it to stay open. So this is a test we can do. But you can use a scan tool. However, we're not going to really actually run the solenoid. We can activate it, but it's not going to open the switch because we have no vacuum applied. We're going to go to the actuator test mode, and we're going to activate the LDP test. Here it is in still form. Let's show you what's up here. First of all, the red trace at the bottom is the LDP switch. It can be used to activate the LDP with a 50% duty cycle. But as you notice, the sense switch does not open because we have no engine manifold vacuum. Now we'll take a look at this. When it's grounded, which is what we used our jumper lead to do, we can activate the solenoid. Here's actual film moving around. This is what you're going to see on your scope to verify the solenoid is doing. We're going to use the field test. We're going to actually go into the car, put our hands on it, and see if it clicks. We call this the click test. If the solenoid is clicking when we have it activated, that's fine. The point we're trying to make here is the actuator test mode tells if the solenoid is working. It does not tell us if it pulls a vacuum. We do that manually like we showed you in the diagram. You cycle it on and off 3 or 4 times, you'll find it stays up. If the pressure stays up, the solenoid is working and the manifold vacuum is holding it open and the system is holding pressure. You pass your manual test. Now you might want to go have a look at smoke testing, because we think smoke testing is probably the most practical way to test this, and we'll show you how to block it off and do a smoke test. In smoke testing, the LDP.